those areas, and yeah.
It's probably 6.
It's probably
Yeah,
6.
it can't be negative.
And then I went and I saw this. I went, okay, let's see what variables I have. Oh, I can make a system of linear equations. Bam, -6. So I proved to myself, which is nice.
Right, questions on that? All right, take your notes. Let's talk about alternating series today, which are nice and what most of them end up being. And then we'll talk about ratio test, RIT test, and then we're done with tests. So today we will cover what's in this book on 10.4 and 10.5. Hopefully we get it all done. And then nicely the class starts to get easier. But this, bad news bears. Okay, so today we're going to talk about alternating alternating series and absolute and conditional convergence. Convergence.
So is this step like 7 on our?
Yes, and the good news is we start to break into where, okay, I recognize it's alternating, so I have to go to this. I recognize it's a root, so I have to go to this. I recognize it's a ratio, so I have to go to this. Alternating series with that, and we also talked about the ratio and the root test today. Ratio and root, finally we get to something that like we can use for more than just certain classifications of tests, but the bad news is that they're not that easy. So today we first provide an absolute definition. First thing we talk about is absolute convergence. Oh, I need to take attendance before I get who's gone today. Absolute convergence. A series. Yes, in the bins, there's like dozens of them. A series A of n converges absolutely. Wow. If we're getting there. Thank you. Oh, see where it says class 2010? I think they're behind there. If not, they're behind the class 2008, I think as well. Cabinets, bins. One in the same.
Oh,
Marco, I can't tell if I should be happy or burned. Absolute convergence, series A of an absolute convergence if the absolute value of that series converges. Okay, absolute convergence means all the time, always converges. Conditional convergence is what comes today, sometimes converges. Depends on conversion. But absolute convergence happens if the absolute value of it is. So, for example, let's take a look at example number 1. Let's take a look at a fun one. Let's start at 1. Now, notice these. Do they have any sort of starting point? No. So it doesn't matter if it starts at 0, 1, 7, 15. So let's start from n is equal to 1 to infinity, and let's go -1 to the power of n plus 1 over, let's make it an easy one, n to the 4th power. Yep.
Let me go up just like a little bit. No, the other way. You go
That's where we started today. Oh,
go.
yes.
Thanks.
we go like
Pivot to the left.
Take it back now, y'all.
All right, do this example. Go. Where's Mrs. Kumar? Okay, question. Does this absolutely converge or diverge or conditionally? Well, you don't know. You know that one's not right because we haven't talked about it yet. So absolutely converge or diverge.
I think that absolutely converges.
Okay, so what don't you care about for absolute convergence?
anything.
It's the absolute value.
Hold on. It's the absolute value. Okay, so it's the absolute value. So what doesn't matter? Sign doesn't matter, right? So that -1 doesn't matter if it's positive or negative. We're only looking at what? Right, so the absolute value. And that's our first thing we do for these alternating ones. The first thing we do for these alternating ones is we look to see, is it converging if it was always positive? Now, the good news is some of them who have not converged in the past, but now that we're adding and subtracting, now we're taking some away, so that will allow us to converge on ones that previously diverged. But the easiest test first, we just take a look at the absolute value of -1 to the n plus 1 over n to the 4th, which is equal because absolute value, what doesn't matter anymore? Right, the negative doesn't matter. So that's equal to this. Do we need to put absolute values around n to the fourth? No, because it's also always what? Okay, talk to yourself for 5 seconds. Converge or diverge?
Hey, Joey.
Yeah, I'm not
how's it going?
sure.
Definitely diverges.
How
Oh, it's one. Oh, I'm dumb. Never mind.
What did you think it was?
Yeah, a little bit.
Yes.
Okay, does that converge or diverge? Converges by what? P series. Converges
Yeah.
by the P series test. Why do I keep writing that right? P series.
It's the P
Test.
test.
Well, the P test belong back in integrals. Just insert the word series and now it's series by the P series test. All right, now why does that make sense? Because now instead of just adding repeatedly, we're adding and subtracting. If we're adding and subtracting, okay, well, if we were to write out the first two terms, it's kind of like we're taking the donut, eating the first one, saving the second one, eating the third one, saving the fourth. Well, if adding all the time converged, adding and subtracting also has to do what? Converge, right? Because will it be bigger or smaller? Smaller. And it's like hold on, going to the comparison test, we know that the sum, if it's always positive, is going to be bigger. We know it's going to be greater than 0 because the first term's bigger than the second term, bigger than the third term, bigger than the fourth term. So it's like we're sandwiching it in between, the one that's always positive and 0. And we know if the one that's always positive is bigger and converging, the one that's smaller but yet bigger than 0 is also going to be doing what? Converging, because it's sandwiched in between 0 and a converging series. Stop and check out. Questions on that? All right, should we do another one? Should we do it now? Let's just go to the next one. The next one, now we talk about what if the absolute value converges, then we go the other way too. This is actually a theorem. They call it Theorem 1 in this book, so you reference it for the homework tonight, because I noticed in the last section they used Theorem 3, but they didn't tell you what Theorem 3 was. So this one is absolute convergence implies convergence. So this goes backwards from it. So now if you know it's absolutely converging, actually it would be converging as well. So that goes the other direction. If the absolute value of A of n is converging, then the series without the absolute value is also converging. So kind of weird, it works both ways. If the absolute value is converging, the series is converging. And if the series is converging, the absolute value is converging as well. Now, there's a proof for that. That is for the people that will take gloriously advanced calculus one day. And I will let you experience that one day in all its glory. All right, stop and check out. Questions on that?
Yeah, it's not much different.
Not much. One implies the other implies one. A implies B, B implies A. Yeah.
Well, I'm just saying that it's different, saying it differently, but.
If the absolute value is converging, the regular series is. But the definition of absolute convergence is A of n converges if its absolute value does. Now, why is that going to become important to the...
That's the same thing. Exactly. You're saying that A of n converges if the absolute value converges, but if the absolute value converges, then A of n converges.
Different word. I'm saying it absolutely... Hold on. Different... No. Different word. It absolutely converges if its absolute value does. And if its absolute value does, now we can imply regular convergence as well.
Okay.
Converges for all values. And that's going to come up in just a minute. Need another example or ready to go on?
Ready to go on.
That's one.
I'm ready to go on.
Ready to go on. Okay, let's continue to talk then. Let's go on to, do I want to take that one? No, let's talk about conditional convergence, because that will really start to address Jaden's question. Conditional convergence. So, like if it's conditionally approved, you have some conditions you have to meet for it to converge. An infinite series is defined to be conditionally convergent if the sum of A of n converges. But, okay, we're going to talk about absolute value. If the absolute value converges, this has to converge. That wouldn't be conditional convergence. So what does the absolute value have to do? Yeah, absolute value. What's it going to have to do then? Diverge, right. Now, this is going to seem opposite of intuition. This one could be alternating between positive and negative, but if they're always positive, it's going to diverge. But if you're adding and subtracting, so eating some donut, keeping it, eating some donut, keeping it, that would converge, but the absolute value diverges. That's conditional convergence. If the absolute value diverges, but the series itself converges.
Quick question.
Not taking questions today, sorry. Well, and I don't mean all day, but let me get through a couple things and then I'll take questions. Because sometimes things make more sense when you get to a stopping point, not just stopping at every point. Okay, so what's that mean? The absolute value diverges. In other words, if we're adding all the time, like 1 over the square root of n. 1 over the square root of n does what? Diverges. But what if you alternate between positive and negative? So in other words, you have -1 to the n power over the square root of n. Now you're adding, subtracting, adding, subtracting, adding, subtracting. Is that going to converge or diverge? Okay, so then theorem 2 is our boy, Leibniz. L-I-E-B-I, Leibniz. There we go. L-E. Leibniz test.
That's a name.
Yeah, that's a German guy who this was his thing. Leibniz test for alternating series. Hey, don't laugh at that. People made fun of Newton when he was trying to discover his gravity or whatever magical force existed only in his brain. And then it turned out he was true. So Leibniz, yeah, that's a Z at the end. I make my Z's like this, and I don't know why, but some college prof made me in a class, and then I just kept doing it.
Is Leibniz spelled T-Z?
Nope.
No.
No TZ. Let me Google that real quick. We're going to use it so much you'll remember it whether you want to or not, and then that'll become a 4-letter word in your vocabulary. Okay, there's a lot of conditions in this one, so you got to hang with me until the end, and then we'll go back and explain it. That's why I didn't take questions, because this one's going to assume a lot of stuff. So assume. Yeah, I know. Okay, there's a lot to this, but then there's a really good outcome to it at the end that allows us to look at it. So we're going to assume that A of n. Assume A of n is a positive sequence. Okay, let's go through the easy stuff first. Positive, that means all the terms are what? All the terms are positive.
What are those squiggly things?
A bracket.
What? No.
Wait, why is that a bracket? Does it have to?
Why don't we just use
Whoa, wait for it. Like I told you, wait for it. I'll take questions when I'm ready. Whew. Whew. Calm down, people. Is a positive decreasing. Okay, here's why we use a bracket. Oof. A bracket, third time I've said it, is a positive decreasing, not series, but sequence. That's why I put the brackets around it, because it's denoting all the terms that would belong in there, A1, A2, A3, A4, A5, all the way up to A of n. Okay, that's important because it's a decreasing sequence, not a decreasing series yet. And, yep, A of n is a positive decreasing sequence and converges to 0.
What is on the end of it?
Decreasing.
Just is it positive decreasing?
Positive and decreasing. In other words, the terms are getting what? Smaller, right. So like 1 over n squared. Always positive, always decreasing, converging to 0. Okay, but that's the thing. We're not really looking at what's happening in that. So let's take a look at what's going for that. So that means that the first term is greater than the second term, is greater than the third term, is greater than the fourth term, ... and then A of n is greater than 0. Because it's turning. Guys, if you stop talking for a minute, I'll focus on writing instead of focusing on trying to listen to what you're saying. I'm running the class, you're the students, do your job and I'll do my job, but don't complain the whole time and wonder why nothing's getting done. Seriously. You get up and give a speech and have people talk the whole time you're trying to do math and wonder why you can't do it. Don't make me get Kumar in here. Trust me, she's going to be in a fabulous mood. And nobody else wants to teach this stuff. So. Okay. You kind of want candy? Really? You're that guy? just go over there and buy some. Okay, so all the terms are getting smaller. All the terms are positive, then they're all greater than 0. That's important for this because we're going to do stuff with this. Then we're going to make it an alternating series. So then we're going to make it alternating. So we're going to have a sum is S is equal to the sum. That's equal to the sum as n equals 1 to infinity. We're going to alternate, so we're going to have -1. We're going to raise it to the n minus 1 power. Okay, why is that there? Because when you plug in 1, what's 1 minus 1? Well, that's going to make that what? Positive. So it's going to make the first term positive, which is actually important. Earlier in the chapter, I talked about reindexing these, and 99% of the ones we need to reindex are just to make the positive and negatives match what we need them to do, to make the first term positive, the second term negative. So then we're going to take that times a of n. So now this is equal to a of 1 minus a of 2 plus a of 3, dot, 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 a of n. If this one converges, then this one converges. Now notice there's two key things. So this test says if we start with a positive term, so if a of n, so if this is an alternating, if this is an alternating series and the sum from n equals 1 to infinity of a of n converges, then the alternating version converges as well. Okay, so now we get to this example that kind of blows things up because we've been saying forever that this diverges, but this is going to sometimes converge for this one. What conditions does it have to meet? They have to be decreasing, they have to be always positive, they have to be going to 0, but now they're alternating. So this is on purpose, that this is one that has been diverging the whole time, but now we're going to show that it may converge. Now we're going to show that it may converge. Can I take this off? Okay. Give you a second to copy. So in previous sections, what we've done is we've talked about ones that are converging or diverging. Sometimes, if it was geometric, we were able to actually find the sum. Sometimes it wasn't. And it is frustrating because we talk about converging and diverging, but we don't talk much about what it's converging or diverging to. We'll be able to do that with some Taylor series and some Maclaurin series to actually find out what it's equal to. But the first thing we have to do is determine, is there even a sum that exists? Also, some of them we can't find out. Like some of those integrals, we don't have a method to approximate. We don't have a rule. They don't work for any of the things we talked about so far, so we have to use something called numerical analysis. If you're going to be an engineer, some of you will have to take that because we have to be able to find the approximation of the answer even if we can't find it directly. What are the techniques for that? There's a whole class on it. This ends up being in there too because some of these we just can't find by hand. We have to approximate them numerically. We have to find methods that allow us to do that. But the first test is there even one that exists? And it is frustrating because we get into this. It's pretty hard, but there's so much more to it. And numerical analysis is a class like linear algebra that's just incredibly tedious. It's not that hard. You just have to keep doing these reiterations of the same algorithm over and over again. Okay, now this one will blow your mind because we've been preaching its divergence forever, but now it's going to converge. So let us take a look at, I don't want to re-index right now, so we're just going to take a look. So we'll look at example, is this 2 for today? So we're going to look at the sum from n is equal to 1 to infinity of -1 to the n minus 1 over the square root of n. So here's the question for it. Does this absolutely converge, conditionally converge, or diverge? Okay, so in the back of my mind, I'm going to write a question before we even get to this. Is I should have put this above this one. Sorry, I thought about it in between classes and I forgot to write it down and what I wanted to do today. Is it easier for a decreasing positive series or alternating series to converge? Is it easier for a decreasing positive series or decreasing positive alternating series to converge? Because that's the crux of the understanding that we have to get from today. Is it easier for a series that's decreasing in positive to converge or decreasing positive and alternating to converge? Decreasing positive and alternating to converge. Okay, talk to somebody around. Which one's easier to converge? And easier is a relative word. It's like Jenny Hall wants a speed limit, but there isn't a speed limit in this intersection. Easier. Decreasing positive series or decreasing alternating series? Decreasing positive alternating series to converge. Okay, talk to the person sitting next to you. Ready, set, Matt.
Alternating applies to the ones that are always positive. It's about the absolute value.
Absolutely, it basically goes from negative to positive.
Okay, for some insight here, I have two. Okay, are these sequences or series? Sequences, because there's not a what sign between them. Okay, a better teacher would have written a plus sign in between them. If there was a plus sign in between them, which one would be easier to converge? Or which one even has the possibility of converging? Okay, why does the alternating? Volunteer. Why does the alternating have at least a possibility of converging? Joey.
Since you're adding negatives to positives, you're decreasing at a faster rate your total sum.
Okay, somebody else? Really?
If you don't have any like negatives, then you're not decreasing at all.
Right. In fact, you're universally doing what? Yeah, in fact, for sure, we're growing without bound. Every term is increasing the value of our sum. For the alternating, what's happening? For the alternating one, what's happening?
So it's going back and forth, you're adding and then subtracting, so you're getting closer and closer to a value if that series is decreasing.
Okay. Now, is this series decreasing? No, because the absolute value is doing what?
Diverge.
Yeah, they're not, well, they're getting, the absolute values of each term are getting bigger, right? So it is easier for an alternating series to converge. So when you look at tests, if the absolute value converges, the series is doing what? Close. Got to put a word in front of it. Absolutely converging. If the positive values are diverging, but the alternatings are converging, going towards a number, it's what converging? Conditionally converging. Why? Because the condition is we cannot guarantee it's going to always converge. That's going to depend on where we're looking at, and that's going to depend, on the radius that we look to converge. And notice I'm throwing that word out there, even though I haven't defined it yet because it's a couple days ahead of where we are, but I want you to have that in your brain. Jen?
So in saying, or in answering this question, saying alternating series,
Yes.
easier, does that mean any alternating series will have a greater chance of converging than any decreasing positive series?
Correct. It has a better shot. Now, do I have an algorithm to determine if it's better or not? That's what we have these tests for. There are many positive series that have no chance of converging. Why? Because all their terms are getting bigger. But if it was alternating, it's like you're taking some, throwing it away, taking some, throwing it away. It's possible that one could converge if all the positives diverge just because the alternating is adding some subtracting. Now, I'm going to throw that question back. And that was actually a really well-timed question. Is that second one converging or diverging? Is that second one converging or diverging?
Okay.
And for the first time, is it possible that it could be converging towards negative, or it could be diverging towards negative infinity? Yeah, because we really kept our hands clean of negative stuff, except for a few homework problems. We worked one either Monday or Wednesday after school. We've kind of kept our hands clean of negative stuff in this chapter so far, just because it's tough stuff, and adding that in makes it harder. Is it possible it could, an alternating series could converge to negative infinity? Okay, is this one? Yes. Is this one? Well, first off, is it getting close to any value? No, because to analyze where it is, we have to at one point do what? Stop. We have to at one point stop. Like if we stopped here, would the sum be positive or negative? Negative, because all the negatives are bigger than the, but the problem is if I just go to 7, then it's back to, hence it is what? Alternating. And that's why even the word comes in alternating. The sum can alternate between positive and negative from one term to the next. The sum, not the term, the sum can alternate between positive and negative just by going to the next term.
So how could it possibly converge if it keeps alternating between big negative and big positive?
Alternating has a possibility because you're adding and taking away, adding and taking away. If we were just strictly adding, it has no possibility of converging because the sum's always getting what? Nothing bigger. So at least think of conditionally as a moment of pause. It could converge. It might converge. Sometimes it will converge. But if they were all positive, there's absolutely no way it would converge. In fact, let's look at this one up here. Let's go back now to that example that's terribly ill. Where's McCutcheon when I need her? Okay, let's look at this one. If we didn't have the negative 1 on the top, would this converge or diverge? If we didn't have the negative 1 thing on the top, the negative 1 to the power of n minus 1, would it converge or diverge? Diverge, because it'd be what?
T-series.
Okay, let's look at this one now. Does it absolutely converge, conditionally converge, or does it still diverge and I'm just playing games? Okay. Give you a minute to think about it, work on it, do what you got to do. Look back at our boy Leibniz, see what he's got to say. And there's no T, by the way. I did actually spell that correctly just by thinking about it. There is no T, Leibniz.
Leibniz.
Leibniz, it's German.
I know, but I don't actually correct.
Wait, so you're asking?
Hold on, can you make that your senior quote? I don't like being correct. I don't what? When did that happen?
Last year.
Why?
No, they
Or like-
I swear they had senior quotes.
We had them last year, we didn't advertise them because they are the worst thing ever.
Why?
Because we have to go through and check every single quote to make sure nobody's trying to speak in anything inappropriate, because it's happened every single year since the school.
Yeah, but that's
started.
okay.
Cares.
Yeah.
So we have to do that. I have to do it, and then Miss Savage has
Hold
to
on,
do
I
it.
gotta mute this.
And then we have. to
Sorry,
make
Internet.
sure, like, all the photos are
We'll be back in
okay.
just a second.
And then people send in photos late, so then we have to go back and reload them and check to make sure every single person.
Because I'm not gonna lie to you, Mr. Bailey probably doesn't even know that happened, so. But,
Well, the yearbook gets in trouble because we allowed it to be printed, and the school gets in trouble because it was school publication, and then whoever sent it in gets in trouble.
where's the accountability to the student? Why doesn't the student do that something inappropriate?
They get in trouble too, but so does the
Okay,
yearbook.
so that throws the statute. It's really
God
hard to get
forbid
seniors
the
in trouble
public
after
knows
that.
what high school students talk about.
All right, let's go to something more interesting, though. Let's go to something more interesting. Okay, okay, so let's go back to our boy Leibniz. He says that this series to be converging, because is this alternating? Is it alternating? It has to meet what conditions? It has to be positive. It has to be, and they have to be what? Positive, decreasing, and what else? Okay, are the terms of the sequence positive and decreasing and going to 0? So, okay, let's write out a few terms. Square root of 1 over plug in 1. 1 over the square root of 1 is? 1. Next one, 1 over the square root of 2 is? Okay, 1 over the square root of 3 is? The square root of 4 is? Square root of 5 is? Okay, are they always positive? Yes, the square roots only kick out what? Positive, right. And that's the kicker that usually gets us. If it ever could kick out a negative, that's going to be in trouble. So they're all positive. And we're just looking at 1 over the square root of n. We're looking at the original series. Is it positive? Yes. Is it decreasing? Yes, because 1 over the square root of 2, yeah, the denominator is getting bigger, so the fraction is getting, and are they converging to 0? In other words, if we took as n goes to infinity, is 1 over the square root of n going to 0? Yes, it is. Therefore, this alternating series is converging. Now we got to figure out, is it absolutely converging or conditionally converging? To look at that, we have to look at the original series. We have to look at the original series and not the alternating. 1 over the square root of n, is that converging or diverging? Diverging. So let's go down to example 2 here. Okay, since 1 over the square root of n, 1 over the square root of n, and I should put sum as n goes from 1 to infinity. Doug question, why can't I start at 0 for this one? Yeah, bad news bears. 1 over the 0 is 0. It's trouble. So since this sum is always positive, it's always positive, it's always decreasing. Yeah, I'm going to get a different marker, sorry. The orange one seems to be the only one's working anymore. It's always positive, it's always decreasing, and the limit as n goes to infinity of 1 over the square root of n is equal to what? 0. The sum from n equals 1 to infinity of negative 1 to the n minus 1 over the square root of n is converging. Now, is it absolutely or conditional? Then we got to look at what's the original one doing. It is converging. So then we still have a question. Is it absolute or conditional?
Mr. Beckman?
Yes.
You said 1 over the square root of n diverges.
Hold on. Hold on. The limit as n goes to infinity of 1 over the square root of n is equal to what? 0. Hold on. So this is converging.
No, that's the divergence test and.
Hold on, Arjun. Hold on, Arjun. Hold on, Arjun. It's converging. Whoa, Arjun. It's converging. So now we have to ask the question, is it absolute or conditional? It is converging. That test is going to depend on what? Shh. I'll take questions when I'm ready. How do we test to see if it is? We look at the original. Wait for it, people. Because what are you doing in this? You're adding and subtracting, adding and subtracting, adding and subtracting. So there are going to be some that are converging now that we're alternating, that we're diverging when we were just adding, which makes sense because if you add and subtract, add and subtract, add and subtract, especially if you add and subtract with decreasing numbers, the amount that you're adding and subtracting is getting smaller, right? This is converging. We got to figure out if it's absolutely or conditionally. How do we do that? It's absolutely conditioning, absolutely convergent if the absolute value of this is doing what? Converging. So let's look at the absolute value. Now, Arjun's right. If these were always positive, what would it be doing? Diverging, right. But what are we doing? In fact, remember when I introduced this example, I said it would blow your what? It'd blow your mind, because this is one that we have preached for weeks as positive diverging, but as negative, it actually can converge. So we look at the absolute value. So the sum from n is equal to 1 of infinity of the absolute value of this over the square root of n. Okay, notice I've been asking the same questions with different types. What matters when you get the absolute value? Just the square root, right? Because the negative 1 doesn't matter because the absolute value would make it positive. So this is equal, and notice I am using the right word. This is equal to n equals 1 to infinity. Hold on, I'll take questions in a second. So does this converge or diverge? Diverges. Just a second, people. Hang with me. Whew. 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 Hold on. Whew. Whew. So let's go back. Oh, yes, I can move it up. This way?
Yeah.
Okay. So then, I'm going to show this, even though I'm going to not put it on the screen real quick. Conditional convergence. An infinite series is defined to be conditionally convergent if the sum of A of n is convergent, but the absolute value is divergent. And Leibniz's test told us if it's positive, decreasing, and the limit or the terms converge to 0, the alternating series is what? Convergent. We just got to figure out which one of the two it is. Is it conditionally or is it absolute? Now, because this diverges, what is this puppy? Go back to the original one. What is that puppy doing? It conditionally converges. So, therefore, the sum from n equals 1 to infinity of -1 to the n, is it n minus 1 or n plus 1? N minus 1 over the square root of n conditionally converges. Now, the problem in reality is if we actually find the sum, we have to find a what? We have to stop at some point. And the problem with stopping with something that's alternating between positive and negative is the next term is going to do something different than the term before it did. So yes, this is going to blow your mind. I prefaced it with blowing your mind. You still didn't believe me that it was going to blow your mind. But this one is conditionally convergent. Why? Because the Leibniz's test gives us 3 conditions. It has to be positive. All the A of n has to be positive. And notice A of n, 1 over the square root of n, is always positive. It's always decreasing, and the terms are heading to 0. So therefore, the alternating series either converges conditionally or absolutely. When does it converge absolutely? If the absolute value of that is converging, the absolute value of that is converging, then the term, I said that wrong again. If the terms converge, then the absolute value converges. It conditionally converges if the original one, 1 over the square root of n, diverges, but alternating it converges. So now it's like we got conditions on the convergence. If we take away the alternating part of it and it diverges, it's conditionally convergent. If we take away the alternating part and it still converges, it's absolutely convergent. It's always going to converge. So it's a weird one because if we just look at 1 over the square root of n, it diverges. You're absolutely right. It doesn't approach the sum. I've said it 3 or 4 times. It's hard to understand because we just have an infinite number of 1/2s. But if we alternate between positive and negative, those 1/2s go away because every term will cancel out a little bit more than the term before it did. What is that going to do to it? It is going to have a convergent sum. Jenny.
So, the sum of 1 over the square root of n diverges.
Absolutely. Oh, I shouldn't say that word. Yes, it does. Absolutely is a really confusing word for me to use at that point. 1 over the square root of n from 1 to infinity absolutely diverges. Does diverge. I gotta stop using that word.
It does also absolutely diverge, so.
Divergence is always absolute. You can't have a condition.
Yeah.
Divergence is always.
Yeah.
If you're growing without bound, it's not conditional, it's always. Yes. So yes, Jenny, the original one does, but now that we're alternating it, what does it do? Now that we're alternating it, conditionally converges. Why? Because 1 over the square root of n diverges, but it meets Leibniz's test that it's positive, decreasing, converging to 0. Yep.
So how do you know like the terms are going to 0?
Let's take a look at the terms of the original sequence. Hold on a sec. Can I use my calculator to help me with this? Okay, so let's take a look at 1 over the square root of x. Okay, so if I look at 1 over the square root of x, as x gets larger, are my terms doing 3 things? Are they going to 0? Are they always positive? And are they decreasing? And look at my y values. What are they always doing? Are they getting smaller?
Yes.
Yes, they are. I plugged in the whole sequence or the whole term in there. 1 over square root of x.
Why did you put that? Isn't it alternating?
Blew a lot of our minds.
I did blow a lot of your minds. Okay, hold on. Let's go through one more time. Hold on. Leibniz's test says that it will converge if it meets 3 criteria. An alternating series will converge if it meets 3 criteria. The original terms, A of n, not with the -1 involved in it. Not with the -1 involved in it.
So it says the terms are going to 0. It means the terms of the original without the alternating.
Right on.
Okay.
If those are meeting 3 things, if they are going to 0, if they are always positive and always decreasing, the alternating series will converge. Because notice at the start of that definition, remember everybody was throwing a fit that I have A of n in there. A of n needs to be a positive decreasing sequence whose terms are converging to 0. Why? Because that was not to be confused. We were not talking about the series of those terms, because the series could do what? Series could diverge. This is an example of a series that diverges. But we weren't even looking at a series. We're just looking at a list of numbers, because all it needs is 3 things. It needs to be positive, decreasing, and converging to 0. Remember when you were fighting me that I was putting the wrong thing up there, but I mentioned that sequence was important, because what would the series be doing? Series could possibly be diverging, but it doesn't matter, because we're just looking at what the terms are doing, not the sum of the alternating or the sum of the terms in the sequence. The sequence, the list of terms that are written in order from first term to our last term, which of course we're going to infinity, so we don't have. But the terms of the sequence are positive, not the alternating version of it. Aaron.
So the original isn't the one that you're given. You have to like go backwards to find the
Right on. We have to take the alternating part out of it to use Leibniz's test. And we're not even considering a series. We're just considering the sequence, the list of terms.
Wait, what were the 3 things?
The sequence has to be positive, decreasing, and the terms have to be converging to 0. In other words, the limit as n goes to infinity of A of n has to go to 0.
With a square root, can it be negative, like if you have 1 over the square root of x?
That would be, well, it could be 1 over the square root of x, in which case you'd have to be going from negative infinity to negative 1. And that hold on. And that would indicate your teacher probably hates you, but I guess we could do that. Other questions? Would you like to work another one? Okay. What should we do? An easy one or hard one? Let's do an easy one, and then I'll give you a hard one. Example 3. Let's go for the sum from n is equal to 1 to infinity of, let's go for -1 to the n plus 1 over n. Okay, with an alternating series, we could get 3 answers. It's not just converge or diverge. It could be absolutely convergent. It could be conditionally convergent, or it could be divergent. Right. Sorry, your talking's interfering with its ability to focus. It's n plus 1, yeah. Now, question, does that matter? No, because is it alternating between positive and negative? Absolutely, yep. All right, does that converge or diverge? And why not? Let's give you another fun one. What else should we give you? Fine. Fine. Ready, set, math.
So can you only conditionally converge, not conditionally diverge?
Divergence is always absolute. I mean, if you're going to infinity, it's not like you're conditionally going to infinity.
Right, so it's -1, whatever, check the line.
We're not talking
Okay, hold on, is it all these? What kind of? Yeah, Mr. Becker.
Hold on just a sec. I'm working. I'm trying something out here, seeing if this is going to work. Yes, Joey.
So-
It does. Okay, that totally works out. Yeah, never mind. I'm going to use this one to do something. Okay.
So when it's alternating positive and negative, how
Yep.
are you figuring out if that specific equation is diverging?
How are you doing? Okay, your first test is, okay, we go to Leibniz. Okay, so if this is our full one, look without the negative, in which case for this one, we're just looking at 1 over n.
Which does diverge.
Yes, which does diverge, but that's not what we're looking at for the alternating. We're looking at it meets 3 things. Is it positive? Is it decreasing?
Okay.
And 3 is the limit of a of n as n goes to infinity equal to 0. If it is all 3, then sum of -1 converges. Then you just got to figure out, is it conditional or is it absolute?
Okay. Okay. Got it.
So just to put it in, I'm going to try it a different way. And I know it's hard. Alternating's hard because now we're not even just adding all the time. Now we're adding and subtracting. Look without the negative. So in this case, we're looking at 1 over n. If the original one, though it's left over after you take out the alternating, is positive, decreasing, and the limit is a of n as n goes to infinity is equal to 0, it's converging. Then we just got to figure out, is it absolute or is it conditional? If it's absolute, then this is also going to be converging. If it's conditional, then this by itself would be divergent. So then, second thing we do is we look at, is it absolute? Hold on a second, let me get my note out on this. Is it absolute or conditional? And again, we look without the negative. If 1 over n converges, then it's absolute. If 1 over n by itself diverges, then conditional. Okay, now another question that came up. Okay, what if you go through here and this doesn't meet those 3? Then it's doing what? Divergent. Because we know if the limit of the terms is not going to 0, it's going to be doing what? If the terms aren't going to 0, every single series on the planet does what? Yeah, it diverges. It goes to infinity. Now we also have to open up the possibility with alternating. It could be going to negative infinity. If you wrote some crazy rule that made all of the even terms really big and all of the odd terms really small, it could actually be going to negative infinity. So it's not just infinity. There exists now the possibility it's going to negative infinity. It doesn't really matter because all we care is doing what? It's not converging, it's diverging, right? Okay, now, let's go back to this one. Does it meet these 3? Is it positive? Yes. Is it decreasing? Yes. Are they going to 0? Yes. So now we can say our answer is going to end with what? Convergence. Now we go to this. Look at 1 over n. Is that converging? No. So it's doing what? Conditional convergence. Okay, let's talk about error bound on the sum. Now, the frustrating part of this is we don't know the sum. Sorry. We do only if it's what at this point? Geometric, right. We don't know the sum. We don't. But, and it's a big but if Leibniz is satisfied, in other words, decreasing positive limits are going to 0, we can bound the sum. We can bound the sum. In other words, we know it's between 2 numbers. And the nice part is it's between 2 really easy numbers. Oh yeah, sorry. And it's between 2 really easy numbers. If S is the sum of -1 to the n plus 1 over, we'll just use the one we had before, n, and it satisfied all 3 of those conditions Leibniz set out, then the sum is between 0 and your first term. We don't know where it is. What's that? Right. Can't be bigger than the first term because the second term is going to do what? And then the third term is going to, and then the fourth term is going to, yeah. And that's from n is equal to 1 to infinity. All right, so a duck question. What's the first term of this one? We'll plug in 1. What's that going to be? Well, what's 1 plus 1? Negative 1 squared is 1. What's 1 over 1? Right, so the sum for this one, we don't know it, but we know it's between 0 and 1. No plus or minus. No plus or minus, because the terms have to be positive and it has to start at 1, which means the first term has to be, and because it's decreasing, your first term is the biggest term, right? So the next term is going to subtract a smaller amount. Yes. Okay. Error bound. Oh, it's 10:20. Never mind. You're out of class. Have a good weekend. If you will need to take some pictures.
Don't do drugs, caffeine.
Okay, the bad news is you also have to flip pages. So there's 2 pages on here. I put stars in the upper corner of them, take pictures, and be happy and merry. I may make a video that you have to watch this weekend on Airbound. The good news is it's not very long.
Oh, wait, and finally, like,